a set of data that has 3 different traffic routes. And so we have the time in minutes for each of the 3 routes. And we want to look to see if there's a difference between them. That's what we do in ANOVA. We're looking to see, is there any difference in this group or from one group to another? And to go back to when we originally started talking about hypothesis testing, we were looking at the difference between 2 groups, and now the only difference is we're looking at more than 2 groups. That's when we would use ANOVA. But it's telling us basically the same thing. Is there a difference? Now, when you have 2 groups, if there's a difference, you know it's between the 2 that are involved. With ANOVA, it doesn't specify which one is different from the other. So when I'm looking at 3 routes here, it doesn't tell me that, all 3 of these are different from one another, like 1 is different from 3 and 1 is different from 2 and 2 is different from 3. It doesn't tell me that. It just says that there is a difference, or we're looking for, is there a difference? So it could be 1 is different from 3, or 2 is different from 1, or 2 is different from 3. Or is the key word there. It could be any of those options in the case of ANOVA. So an ANOVA test is telling you if there is any difference within the groups. So when we look at the bar plot of the 3 routes, in theory, there could be a difference between 1 and 2, right? 1 is higher than 2. So you could find a difference between those, or between 2 and 3, and then obviously between 1 and 3. So there could be a difference between any pair of them. But what we don't know from this graph alone is how much variation there is within each route. So if I'm looking at just route 1, the average is here around 31, but how much variation is there around route 1's average? How much variation is there around route 2's average? And because I only have a small sample here, that variation is very important, because I could have just got route 1 being greater than route 2 by chance, and route 3 being less than both of the other routes by chance. When you have a small sample, that's entirely possible. So you have to take in consideration how different are the groups and how much variation is there within each group. So here's the same information on the previous slide over here. So these are the route data, and this is the graph. And then we've conducted an ANOVA analysis. And to conduct that ANOVA analysis, really you just go into, well, let me go back a couple slides. You go into Excel, go to the data tab in the data analysis. You can select ANOVA, and then you highlight the table with all groups of the sample data. So highlight the whole table with all groups of the sample data. If the columns have labels and you choose them, then you check the labels box and then specify the significance level. So here in Excel, I have the data here, and then here's the ANOVA report. Let me just repeat that so you can see it in person. So I go to the data tab and I go to the data analysis, and then among these options here, one of them is ANOVA, and we're just looking at a single factor here. Okay. Now the input range, let me highlight the table including the labels. So I've highlighted the table including the column labels. So I have labels in the first row, and then the alpha is going to be by default set to 0.05, and usually you just leave it there. It doesn't actually matter in any important way what you change that to, other than when you are making your assessment of the results, then you consider what alpha is. Okay, so I have all of this filled out, and then I choose where to output it. Let me just make a new worksheet so it will print out somewhere else. Click OK, and we get the printout of this single factor ANOVA analysis. So it tells me the count in each group, what's their sum, what's their average, what's their variance. We've got that information summarized here. And then we have the hypothesis test result down in this area. Okay, and so just as it's explained in the PowerPoint, we have an analysis of between groups and then within groups that in combination gives you the ANOVA result. The degrees of freedom are listed here. So within groups we have 9, between groups we have 2. All of these statistics go into calculating, all of these data here go into calculating the F statistic, and that turns out to be 0.265. And you compare that to the F critical, which is 4.25. So that's really the end result of the test is you're looking at this F value and you're comparing it to the critical F value. All right, so the same printout here. Factors for calculating F are in this area of the table. Then we look at the F value compared to F critical, and this tells us F is far less than F critical, and so we do not reject the null hypothesis. And what we're looking at here is the F distribution corresponding to this exact data. So when 1 degree of freedom is 2 and 1 is 9, we have F 2, 9. This is that plot here. So this is what we can see for the value of the F distribution that we got was F equals 0.27. So that would be over here. And so you're talking about quite a bit of area under the curve. The critical value would be here. So from this point to the right represents 5% probability. And so we're clearly well above that in terms of the probability value. If you're curious, I made this graph using the link back here for stat distributions. So if you click and open that up, you can put in p-values and f-values, and it'll show you what the F distribution looks like and show you the area under the curve for that. Okay. Now in Excel, you can also calculate the left tail probability using the F dot distribution. So you can put in the values here and get the probabilities if you want to do it that way. But we have the information, the essential information we need just from this ANOVA report in Excel. And so variation between traffic routes is compensated for by the variation within the routes. So when we look at this data, the variation between them, so one bar being higher or lower than the next, that's compensated for by how much variation there is within the routes. So our ANOVA analysis tells us that we can't distinguish between the groups here. So even though it looks like route 1 is greater than route 3, and in fact its average is greater than route 3, because there's so much variation, it's possible, it's probable even, that you would get a result like this just by chance. So we cannot reject the null hypothesis that all of the routes are equal in terms of their time. The other thing to look for in this is the way that I've plotted here can be a little bit deceptive. So it looks like route 1 is much, much bigger than route 3, but that's because I'm plotting starting at 24 and going to 32. So always pay attention to what's on the y-axis when you're making the comparison here, right? So I could have even made this more extreme. I could have started it at 25 and it would look like route 3 takes almost no time and route 1 takes, a really high amount of time. Or I could have plotted this starting at 0, and that would be sort of more accurate or more fair way of presenting the way the routes look. But I wanted to show you what the differences were so then we could see whether or not that was statistically significant.